we talk about derivatives. When we're given a function, we can use the limit quotient, limit of difference quotient to find the derivative of the function. Then we memorize a bunch of formulas and rules so that we can quickly find the derivative of the function. So now we want to reverse the process. So if we're given a function and want to say, okay, so what function would have derivative equal to the given one? So that we call it an antiderivative. So if we're given a function, for example, if we're given f of x equal to x squared plus 1, then we can say what is an antiderivative of f? So that would be something, some function, so that its derivative is equal to the given f. So then an antiderivative would be, for example, I know that x cubed divided by 3 will give me x squared, right? Okay, because, why? Because if I differentiate x cubed, then I get 3x squared. But I'm looking for something that has just the 1 times x squared, like a single x squared. So I want to divide this thing by 3. Okay, so I want to correct my coefficient. Okay, so if I don't have the 1/3 in blue, my answer should be 3x squared. But if I divide the function by 3, because the 1/3 stays there, right? Then the 3 and this 3, they cancel. I would end up having the single x squared. Okay, so so for the x squared, we know that 1/3 of x cubed will be an antiderivative, and for 1, we know that derivative of x is equal to 1, right? So this would be a function whose derivative is equal to the given f of x. So this is an example of an antiderivative. However, you can also say, oh, let's do +2 or +1 or +1/2. But then you will see that regardless of which constant you add to this function f, after you take the derivative, this constant is going to go away, because derivative of any constant is equal to 0. So now you know that this function has antiderivatives. This is all possible antiderivatives to be 1/3 x cubed plus x plus c, where c is any constant. Okay, so I have infinitely many antiderivatives, but they are all in this format. Okay, so the idea is after we find antiderivatives of each term, then we always do plus c, because when we take the derivative of the function, the c is gonna go away. Therefore, we should always include the plus c. All right. So now let's look at what it means by indefinite integral of f. So indefinite integral of f is just a notation. It's like a way to say we are looking for all antiderivatives of the function f here. So this we call the integrand. Okay, So for example, if I write this, I put the same function here, x squared plus 1, then dx. So the name of the variables, so whether here you write dx or dt or d whatever, depends on the variable that you have in your integrand, okay? So now, what does this mean? This means find all possible, so this notation just means find all possible antiderivatives of what's given here, right? We've done that, so one antiderivative is this, 1/3 x cubed plus x. But if we want to find all, we have to include all possible concepts, like that, okay? So it's just a reverse process of derivatives. Anything that's reversed takes time to process. So we have a bunch of practice for antiderivatives, and you're gonna learn more about integrals in Calc 2. But right now, it's kind of have a feeling about it. Okay. So indefinite integral of a function just refers to finding all antiderivatives of whatever that's given. Let's do one more example. If here I have, let's say, sine theta, okay? So now this function has a variable theta, so I should say d theta here. This is how you write the notation, okay? So now this means find all the functions that have derivative equal to sine theta. So I know that derivative of cosine is equal to minus sine. So to correct that, I'm gonna add the negative sign, okay? So let me write it on the side. Because the derivative of cosine is equal to minus sine. But I want something that will give me sine of theta as opposed to minus sine of theta. So how do I correct my function there? So I'm gonna just add and minus sine to both sides. So minus minus, this becomes plus. So this is what I want. And over here it becomes minus cosine. So now we know if I differentiate minus cosine theta, it gives me sine theta. So one antiderivative of sine is a minus cosine. But then remember, we have to look for all, so we have to do plus any arbitrary constant. Okay? So that's what it is about.